Hello everybody, my name is Jordan Jenkins, and I decided on my blog, I just finished part 2 of my series on learning how to code, and realized as I started typing up the third part where we actually start getting into some serious development that it's kind of complex to try to explain all the different things that I'm going through. So what I'm going to try to do is do a video instead so that maybe things are a little bit more clear, and we'll see how well this goes with me trying to kind of live record this more or less on the fly, not really going through any notes or anything, and just kind of going with things and see if I can keep from being interrupted constantly and various things like that. So what you should have had after part 2 is you should have a file called hello world.rb that you ran to get your hello world. So if we go ahead and try to rerun this here, we're going to go hello, and I'm using the tab key in order to autocomplete when I'm looking for the file name, which is a nice little shortcut that you can use if you need to go in and quickly type things out in the terminal. And you'll see we've got this hello world application just like we had at the end of part 2. And so what I wanted to do real quick was to go through this file and actually explain to you guys what it is that we're doing with this command, because we just kind of typed this in and I just said do it, and you just did it without really thinking. So what we did was we called what's called a function. So all programming is really based on mathematics, and in math a function is something that takes some kind of an input and generates some kind of an output. So in this case, what we did is, using this puts function, we passed in the parameter, or the input of it, in this case was hello world, and the output we got was what was put out to the screen, which was to put it out into the screen. So what we did was we've done a mathematical equation, if you will, and we said, okay, this hello world, this needs to be put in. Now if I change this up and I say, okay, let's change this to hello Ruby, and we go and we run this again, you'll see now it says hello Ruby. So it's very easy to go through and make changes to your code and everything, and realize that that any of the commands that we really say what those are functions that are being called for various things. So one of the things to note is that what we're doing is we're passing in a what's called a string, and a string is really just text. And unlike commands that we're feeding into the computer, what we're doing is we're giving them and saying, this is explicitly what I want you to handle. So what I'm going to do is I'm going to actually take out those quotation marks that I put around the string, which denote it to actually be literal text that we want to manipulate. And if I save that and I run this again, what you'll see is I get an error. And this error says undefined method, and what that means is that it tried to interpret the words hello and Ruby as some kind of command to run. And what it found was that it couldn't do it, those commands didn't exist because those haven't been defined, and so it crashed out and it said, well, I don't know what to do here, so I'm just going to stop. I'm going to stop what I'm doing. And that's the general flow that programs go through, is unless you do some kind of special handling, which we'll get into way down in the future, generally when you make a mistake in your programs will crash. They're going to stop doing what they're doing exactly where they stopped, and you'll just notice that you get an error. So if we go back, you'll see that you got this error. Later on, what you'll see as we start doing more complex operations is you'll see a bunch of other stuff that comes below this. But the main thing to know as you're debugging your applications, and the term debugging is a little bit of a misnomer because there's not really any. We use the term bug for anything that's a defect or anything that's incorrect with the program. And those come into a couple of different ways. So one of the ways was one of the things that can go wrong is what it is in this case, which is what's called a syntax error. And when we say syntax, it's kind of like grammar. It's kind of you've kind of made a grammatical error in your code. So in this case, the mistake that I made, the grammatical error that I said was I didn't wrap this string in quotation marks to say, okay, this is literal text. This isn't something you need to interpret. And so I made a mistake, and it told me, okay, that's wrong, and punished me by crashing my application. Now, when I go in and I run the application, let's say I wanted, instead of it saying hello Ruby, to say hello world. That's not actually a syntax error, because it actually ran correctly and it did give me something, it just didn't give me the right answer. We typically call those logical errors. So they're a little bit more difficult because they don't immediately tell you what the problem is. You'll have to do kind of a little sleuthing, which gets easier over time as you're going through things. But the main thing is to kind of always keep a mental model of what your application is doing. And in this case, we know it's only one line, so it's pretty easy for us to fix. But down the road, it would be a little bit more challenging, as we have multiple lines of code. So what we're going to do is look at kind of what some more advanced things that we can do. So we've already kind of talked about what's called a data type. So there's different types of things we can have that we can put into this puts function, for instance. We've already shown a string, which is just text. Some of the other things that we can put into it that are like basic data types that you typically work with a lot is mathematics. So I'm going to put the number 10, which I can just define explicitly in my code. And if I run my code again, okay, I've got 10. And likewise, I can have what's called what you would call a decimal. There's actually a technical term for that called a floating point number, which really just means it has decimals in it, and it's not an integer or a whole number. So if I do this and I run this code again, all right, there you go. I've done the same thing. And now this is a actual program, and this is actually a computer. And computers were originally invented in order to do mathematics. So what I'm going to do is I'm going to open up what's called the interactive Ruby shell, which when you installed Ruby and got everything set up on your Vagrant VM, you'll see this command will work the exact same. So when I type that in, it dumps me into a different looking shell. It kind of has this, what this is the version of Ruby that I have running right now, and then I have line numbers. So I'm on line 1 right now, and so every line that I run is going to be evaluated immediately after I type it. So for instance, if I want to know what the sum of 10 plus 89 is, and I type that in, I get the result back, and you see it kind of gives me this arrow saying that's the output. So I fed it in on this line number 1, and then I get the output immediately. So for instance, if I wanted to do, say, let's take a little bit more fancy math problem and do 76 plus, 64 times 123 minus 65, and we run that, we'll get what the result of that was, which is a fairly large number, and if you wanted to verify that, you could put that in your calculator. One of the things you'll also notice is this obeyed the order of operations, so it went and added these two numbers, subtracted these two, and then multiplied them together. That will become important, later on, or if you start doing more complex mathematics, you'll get answers like that. And similarly, if we wanted to do, 0.23 or something like that, and run that, you'll see we get a floating point number. And these are what I call, basic data types, or ways of representing information. So we've kind of done the two main ones that you're going to see before we get into anything really more complex. So one of the interesting things that you can do is right now what we're doing is we're typing in all of this information, trying to get these numbers, but we're not able to really do anything without having to go back in and do the numbers again. So if I wanted to say add 10 to this line right here on line 2, what I'd have to do is I'd have to type it all back in again, and then add 2 to it. And yeah, you can do that, but that's interactive. At that point, what we're doing is we're not feeding the computer instructions. We're manually telling it line by line, which computers do this stuff in its sleep, and what it'll take 2 milliseconds to do, we've just added 1,000 times more inefficiency by having to go in and manually do it ourselves. And so what we can do instead is we can actually store numbers, strings, other types of data into what's called a variable. And a variable is really just like kind of an algebra, if you can remember all the way back to high school math, is anything that can change within your program or within a function. So for instance, let's define a variable. We're going to call it my variable, and let's set that equal to 10. and apparently it's now called May variable because I fat fingered that. But you'll see now if I type in the name of my variable, it holds the value that was put into it. So you can kind of think of variables as these little cups that you're putting in, information. If you think of information as a liquid inside of these, and for instance, I can duplicate this if I want to have variable 2 and have that be equal to the May variable. Now if I do variable 2 is a copy of the May variable, so both of those now have the value of 10. And they basically, the variables get treated as the type of data that they are. So if that's those are two integers and I want to add them together, I can do variable 2 plus May variable, and what I'm going to get is the result of adding them two together, just as if I had typed in 10 and 10. And while this seems kind of silly right now, and it doesn't seem like there's a whole lot of purpose to storing it in a variable other than being able to reference it later, what we're starting to do is write programs and actually have information. So I'm going to actually exit out of this and show you guys what I'm talking about. So if we go in, let's go back into our hello world, and let's actually make this a little bit more fun by having variable 1 equal to 10, variable 2 equal to 20, and then give me the results of that. I want to see what variable 1 plus variable 2 is. So if I go and I run this command, what I'm going to see is it's going to go ahead and give me the results of that. So what we just did is we just ran 3 separate commands. We told the computer, first off, make me a variable named variable 1 and make it equal to 10. Give me another variable named variable 2, make that equal to 20, and then give me the results of all of that. So think of this basically as kind of the flow of programming. What we're really doing is we're just telling the computer kind of step by step how to solve a problem that we have. So in this case, I wanted to know what 10 plus 20 was. So this is a way of representing the steps that it takes to do that and then give me the result. So again, we're in the very, very basics of doing kind of programming, so we're not doing anything really hard. But for instance, if I wanted to know say I wanted to take 10,000 numbers and know what the sum of those were, this would be the step. I would just say, hey, give me all 10,000 numbers, add those all up and give them to me. Now, for now, as you guys understand it, I would have to manually type in and have, okay, let's go look at my Excel spreadsheet. Here's variable 3, and that's equal to 30, okay, and go on, and that's kind of tedious. So there are other ways of representing data that we can get into. This is really just talking about how to store information, but there's other ways of grouping information. In this case, we have 3 variables here, and they're completely isolated from one another. They don't know anything about each other. They have no relationship really. So what I can do instead is I can create an array, and you can think of an array as just a bucket that's going to hold several variables inside of it. So let's go ahead and have let's go ahead and make a new array. So I'm going to have array is equal to array.new, and what I just did is I called a class, and a class is a collection of functions that are kind of grouped all together, and I called the new function on top of that. And the way that you call functions within objects is using the dot property. So what that means is if I wanted to call something, I would just put the class dot something. So similarly, if I wanted to create if I want to do call a function to add something into this array, what I can do is I can call array.push, which means put something in the bucket, and I can pass in variable 1. So if I were to do that and then output what array is, what we're going to see is it's going to show me what the contents of that array is. So let's go ahead and do this just so we can kind of take a look at what it's doing. And what you'll see is it gave me 10 because that's the only thing that's in there right now. So let's go ahead and go back into this and add another one in there. So let's do array push variable 2, 2. As you'll see, typing is a huge skill in programming, and it's hard to type and talk at the same time for me. So we're going to run this, and now you'll see we have two values inside of this array. We have 10 and 20. So the advantages that we have here is we've grouped this data together, and we've made it represented by this singular unit. Now, one of the more confusing things in programming, and it's one of those things that you just kind of have to accept, is the way that they are referenced, that things are referenced in an array, is what's called zero based. So, for instance, if I say, give me the results of array, and I want the first value out of that, I say 0. I don't say 1. It's not the first value is 1. The first value is actually 0. So, if I'm gonna actually go ahead and put in 1 here, and we run that, you see we get 20. So one of the things that really trips up people when they first start programming is to remember that the beginning of any type of an array or any kind of grouped set of variables is always 0. It's very, strange, I will admit. It's just something that we've just kind of accepted in the programming world, that everything starts with 0. So, for instance, I can say, give me array sub 0, which is our variable 1, and then I want to add that with array sub 1. So if I save this and run this program, you'll see, okay, I get the results of the output, which is 30. So why would we put anything? I mean, there's got to be a reason why we're putting in it besides just grouping the organization. Right now, what we've written is a program that does the same thing every time, no matter what. So, yeah, it gives us the answer. If we wanted to go through the process of typing everything in, we can get an answer to our problem. In this case, we want to sum up everything. So, what we're going to do, though, is let's do something a little bit more interesting. So let's say if, and this is where we get into what's called a conditional statement. So if variable 3 equals 30, then we want to do something a little bit different. So what I just did was I set what's called a conditional. So what happens is the program is going to go through and it's going to evaluate this variable and make sure that it equals this other variable. Now, one of the things to notice is we use two equal signs when we're doing an equality or any kind of comparison. The reason that we do that is because the equal sign already means assignment, meaning make this variable equal this. So if we said just if variable equals 30, that will always be true because you will have assigned that variable 30 into variable 3. So by doing the two equal signs, we're saying, hey, are these the same? And what that's going to do is make them true or false. So if I go ahead and make this 31, what you're going to see is I'm about to put in here is never going to be run. So I'm going to set this back to 30 so that we fall into this block of code. And a block is denoted in Ruby by being indented. The standard is to indent 2 spaces into your file in order to keep your code organized. The reason for that being that you don't want to, you're trying to make things as easy for you to read as possible. So for instance, everything that happens sequentially we've put into lines one after the other in order for you to know that there is, this is going to happen, then this next line, then the line after that, and so on and so forth. So our program just runs through each of these lines. Now with this if statement, it may run, it may not. It just depends on if what the condition is that we've set is actually going to be, is going to be true. So in this case, what we're looking at now, variable 3 is going to be true. So if that's the case, then let's actually create a new variable and call it result, and make result equal to a string saying, variable 3 is 30. And we're going to go ahead and say, okay, go ahead and do that. And so what happens is that if variable is equal to 30, this variable result is going to be created and it's going to be put, the string variable 3 is 30 will be put into result so that we could then use that somewhere else. So one of the cases that can happen is, well, what happens if we don't, if it's not 30? Well, it'll skip over that line of code, but what can happen is we're going to get into some trouble if, let's say, we want to output what that variable result is to the screen. What you'll see is that I'm going to get into some trouble because if I go and run this now, there's nothing there. Now the reason there is nothing there is, and there wasn't like an error because that wasn't defined, is the way that this put_s function works is it takes anything that you do and it tries to convert any variable that is fed into it into a string. So when something isn't defined or you haven't made the variable name, it is equal to something called nil, N-I-L, and nil stands for nothing. It is equal to nothing. So one of the properties of nil is that when you get the string of it and try to stringify it or convert it into a string, it's going to give you blank. So we got lucky in this case. Now if if I wanted to add something to that, if I said give me the result and add it to variable 2, I'm going to get into trouble because it's going to try to add nothing, which isn't 0. That's not saying it's 0. It's literally nothing, and add it to something. You kind of creates, it's kind of one of those paradoxes of it doesn't know what to do in that case. So most programming languages would tell you, well, that's an error, and you're going to have to go in and fix that. So what we can do is we can set another case that can happen. So what we'll do is we'll have an else, and what the else is what happens is when this first condition is false. So if we have an else case, what we mean is if variable 3 is not 30, then we need to do something else. So let's say result is equal to variable 3 is not 30. So now, if we save this and run this as we are, variable 3 is not 30. Go in and change variable 3 to actually be 30, and we will get that variable 3 is 30. Now, one of the things to note is we told Ruby where the end of a block of code that needed to be executed in these conditional statements was by the indentation, but we also at the very end had this end keyword. And what end means is it's the end of a block of code. So the beginning of a block of code is the conditional statement, and the end of it is either the next statement in the case of this if-else setup that we have, or end at the very end. So you'll notice that if I don't have an else, I have to have this end at the end of my if block. Otherwise, I can get away with just having it set up where it goes straight from the if into the else. Now there's one other thing as we're getting onto these conditional statements is what happens if we wanted to do something if it's a different variable. So say if it's 40, we want to make it something else. What we can do is have what's called an else if. So if you kind of read the code, it starts making a little bit more sense. So the way that we have it right now is what we're saying is if variable 30 is equal to, or variable 3 is equal to 30, set result to be variable is 30. Else, we want result to be variable is not 30, and then give us the results. So similarly, we can have what's called the else if. So that is typed out else if, no e on the end of else, variable 3 is equal to, say, 40, and I'll make that equal to 40, then I want result to be equal to variable 3 is 40. So now I've told it else if variable 3 is equal to, and I misspelled variable 3 is 40, then make result variable 3 is 40. So now if I go and make, then you see we get 40 as our result because we've set variable 3 to be 40. So there's interesting cases that can be happening because these do not have to be the same conditions. I don't have to keep comparing to the same variable. These are completely segmented apart. So let's say I want to say else if variable 2 is equal to 20, to put variable 2 is 20 in here. So what will happen is the way that the evaluations run in programming is, like I said, everything's sequential. Everything's happening line by line. So we'll have set all these variables. We'll create this array. We'll put a couple things in there, and then we're going to start evaluating these statements. So we're going to say, is variable 3 equal to 30? No, it's not. Well, let's go to the next block. Is variable 2 equal to 20? Yes, it is. So it's going to fall into that block and run that code. And then it's going to skip over the else statement and go straight to the end. The reason for that is that these are cases where we want only one of these blocks of code to run. We don't want it to be set over and over again, because otherwise what would happen is every time, no matter what you did, the else statement at the end would run and overwrite this variable that we have. And that's not really what we were going for. We wanted it to just be set in this specific case. So the way that if-else blocks work, which is this kind of construct that we've got right here, is whatever block it does fall into, it's always going to run that code and then skip over the other ones. So similarly, if we take out this else block and if we take all this out, if none of the conditions are met, it'll just skip both blocks of code and just keep going. So it's, this is extremely common. Almost every single, there's no programs really that you can write, kind of out in the real world that are going to, not have an if-else block in there, because let's say, for instance, I want to have a user log in, and I'm saying, okay, this user needs to put in a correct username and password, and for the sake of simplicity, I want the password to be I don't know, cheese. So I want to make sure that, if the password is cheese, then let's make that a string. Then, log in the user. We'll just make a generic function and pretend that's something. And otherwise, then we want to, say no access for you. So there's a lot of cases where you're going to want to have these if-else blocks, and it makes it very easy for us to go through and make sure that everything is controlled and runs the way that we want it to run when certain conditions are met, and it does something different when other conditions are met. So let's go ahead and put this into practice with a real quick example. One of the things I'm going to do is I'm going to go ahead and kind of clear out all this code real quick, because I'm, I guess, too lazy to create another file. And I'm going to go through and I'm going to set, let's have a username, and that's equal to Johnny. And let's have a password, and let's just use cheese again, because apparently I'm in a cheese mood. And what we can do is we can do what's called nesting. So in nesting, what it means is that inside of a block of code, it's just like you started the application over again. So you can actually have more if statements inside of that. So let's go ahead and do a couple of cases. So let's say if username is equal to Johnny, then we want to do something else. We want to print out incorrect username. So inside of our if block here, we've just checked to make sure the username is valid, but we want to make sure the password is valid too. So we can say if password is cheese, we want to put login successful. Else, I want to put out incorrect password. And you'll notice I keep indenting every time I go into a block of code. This is absolutely essential. This is one of those things that you need to be in the strong habit of doing. If you're not using Sublime, will actually do this for you if you have the Ruby syntax selected in this file. It'll automatically indent your code every time you do an if block. But if you're doing this like I am in a manual text editor, then it's very essential to go in and space out all your code. because it is technically syntactically correct to go ahead and have all your code like this, but if you notice as I'm moving this in, it becomes harder and harder to read and understand what's going on. So that's where the convention of indenting everything has really come from, is it helps make it what we call readable. So it makes the code actually such that it's much easier to figure out what's going on. So if we use this, this quick little app that we've written here to do our login, and we run it, you'll notice, okay, login is successful. Now let's change our password to cheese, from cheese to crackers. All right, so we've made our password and we run it. Now it's saying we have an incorrect password. So you'll notice we got through this first loop, so we fell into this big old block of code right here, and we failed this next test because the password wasn't cheese, so it goes into this else block. So through this nesting, it's possible to have more complex applications that check for a variety of things. Now what I'm going to do now is I'm actually going to do what's a fairly common practice in programming called refactoring. What refactoring really is manipulating and moving around parts of your code in order to make it better. And better is kind of an arbitrary word. There's a lot of different ways that better can be construed. But one of the things I'm going to do is I'm going to make this a little bit simpler by saying, well, you know what? If we, for security, let's say, I don't really want to tell them whether the username or password is wrong. I just want to tell them they were not authentic. They didn't log in successfully. So to do that, I would need to check that the username and the password was the same at the same time. So the way that we can do that is to take this line, and we're going to go ahead and move this up, and we're going to put these two ampersand symbols in front of them. So what the ampersand means here, the two ampersand signs, is the symbol when we're doing comparisons for and. So what this means is if username equals Johnny and the password is cheese, then we want to fall into this block of code. So what I'm going to do is I'm going to actually take out the rest of this code, and we're going to go ahead and just change this line from login successful to login failed. Okay, so we've reduced something that was 10 lines of code down into 5 lines of code, and the general rule of thumb is the less lines of code that you have, the simpler and faster your program is. And at the level we're at right now, no matter what you put into it, you're pretty much going to be done in instant time. We're talking like millisecond, or not even milliseconds probably. But for larger programs, things like this do make a very big difference. Or if, say, we were making a website and this piece of code ran, and every time it ran it took a second, it would be not nice for the users, especially if, say, it took a second for all 1,000 people that were trying to simultaneously log on. So you can see right here we've got our two things. So if we go in and we're going to run our code, we didn't log in. Now I'm going to change the password back to cheese, and we're now logged in successfully. So there's another case that can happen in these evaluations. Sometimes we don't care whether which condition is passed. So, for instance, let's say if they have a password of cheese, or they have a password of crackers, they can get in. What I'm going to do is, using the math symbols here, is I'm going to put in these two pipes. Now the pipe is above the return key or enter key on your keyboard. You use shift to get to them. The other one's a backslash. And what these two pipe symbols mean is or. So I want to say or if the password is crackers, then I want this to be successful. So what happens is it's going to say if the username is equal to Johnny and password equals cheese, or the password is crackers, then tell me login is successful. So the reason that we wrap these the two of these around is to group them together so that the program and the code knows that those two are what we're saying or. Otherwise, what would happen is it says username equals Johnny and password equals cheese, or password equals crackers. It gets kind of confused onto which way that's supposed to be grouped. So similarly, I could say, the password crackers is some kind of magic password that is going to let anybody in, no matter what their username is. And so, I'm going to say if the username is equal to, I need to put those as not curly braces, as actual braces. If the username is Johnny and the password is cheese, or if the password is crackers, login is successful. So those are two actually very different logics that we're setting up, and they behave vastly different. So this is where we get kind of into the nuances and kind of pickiness of programming. That was the difference of where I put those parentheses. So something to keep in mind, especially if you're looking at a logic error, is to be aware of where you've grouped some of these more complex conditional statements. And keep in mind that grouping them together like that is a good way to kind of separate everything out and make sure that everything's clear to the program. So one last thing that I want to kind of point out when we're going through and putting programs together is if, say, you wrote this application, we wrote this little file that does our login, and you come back to it in 6 months, and you haven't touched Ruby, you haven't really done anything, it's going to be pretty hard for you to figure out what's going on. And especially as we start getting into thousands and thousands of lines of code, it becomes cumbersome to try to work through what all is going on so we can figure out what things are. So what programmers came up with is the idea of comments. And what comments are ways of leaving yourself little notes within the code that tells you what's going on. So, for instance, I want to say, if username is Johnny or password is cheese, and password is cheese, then I want this code. Then login successful. What I've just done is I've said in plain English, or if you're in a foreign country, your native language of choice, is what it is that code just does. So comments are a good way of catching yourself up on what's going on. It's pretty much essential in software development to comment your code. I've seen some guys comment almost every single line. For me, I typically take logical blocks of functionality and kind of break it up. So one of the techniques in designing software that you can do that I learned when I was first learning how to program is to write out in English what it is that you're doing as comments, and then go in between each of those and actually make that happen. So let's take our login system that we're doing, and let's say we want to ask the user for their username. We're then going to want to ask the user for their password, and then we're going to want to check the username and password to make sure it's correct. So what we've done there, and for the sake of readability with how comments are done in Ruby, it is actually technically proper to space them out one line after the hashtag /#, is I've now basically in a high level described what this application is going to do. In this case, I'm asking for 2 pieces of information, and then I'm going to check it, and then I might say print out if the login was successful or not. So what I've done is I've defined what my application is doing at a very, very high level. What we call the functionality of the application, and really just the high level steps it takes to do what you're wanting your application to do. So what I can do now is I can go in and I can actually start filling this stuff in by just making a new line between here, and then I can go in and say, okay, if I want username is equal to Johnny so on and so forth. Then as you look through your code, all you have to do is look for these pound symbols and just kind of skip through all of your code, and you'll know exactly what the program is doing. One of the other things that the sticklers in this commenting wars that we have as programmers, because we like to nitpick things, is another good practice is at the top of all of your applications is to put a little bit of information about it, just for the sake of one, posterity, ownership, and kind of telling what this file is at a high level, just so you can know. Because eventually what we're going to start doing is working with multiple files, and it's good to know if you're in the right file before you start hunting around for things. So let's go ahead and just, we're going to name this file. So we're going to just call this hello world.rb. And let's put who the author is. So author, I'm going to say it's me. So we're going to go through and say, what's the purpose of this application? So purpose is to check user name and password for correctness. Okay? And that pretty much says what it is. And that's really, that's just, like I said, that's really because that's the first thing that you're going to see when you open up the file. So it's good to kind of say, oh, okay, I know who wrote this file, and I also know what this file is supposed to do. And that can also help you if you're finding a problem. Like, oh, hey, every user that logs in, nobody can actually log into the system. Oh, okay, well, now I know, okay, if I go into this hello world and I know what this file does, then I can know that I'm in the right file when I start searching for why it's not working. So this is a really good habit to get into. It is, I will say, probably the most essential thing that you'll do as a programmer, and it's something programmers do not do enough of. We will be, I think, as I can speak for the collective of all programmers when I say that we do not do this enough, is to comment your code and make sure that it's very clear what it is that you're doing. Some of the other best practices that are just kind of good to start internalizing is there is the principle of that people have of what's called self-documenting code. And what self-documenting code means is that you are aware pretty much just by looking at the code what it is that's happening. So some of the ways that you can do that is, for instance, I've picked, you can pick anything that you want for a variable name. I can call I can make a variable named this and just be random text, and it's still technically valid, because variables can have any name. So in self-documenting code, you want your variables to have a meaningful name. So a bunch of random letters really doesn't tell me what it is that variable is actually supposed to represent. Whereas when I have my variables by the name of username and password, I know exactly what those variables are now. I can say, oh, that means the username of the user, and this is their password. Otherwise, if you need it to be more clear, you would put a comment that says, represents the username of the user. And another similar thing we can do is we can put it at the end of a line. So if I wanted to, put this at the username of the user. If I want to put this at the end, I can also put it at the end, so I can say password of the user. What you'll notice, though, is this has gotten redundant because it's pretty clear, what's going on. So this is where you can kind of over-comment code. So it's good to probably just have one or the other. In this case, I'm going to say I want to be very specific as to what those are and do that. Like I said, it's very good to know, to keep in mind exactly what it's doing. Another thing that you can do is inside of if-else blocks, if you want to kind of summarize what those blocks do, is right after the conditional statement, you can put in a comment here to say what it is that you're now going to do now that this condition has been met. So I can say, print that login was successful. And so now, if I look through my code, I'll know, oh, okay, that's what I'm doing in this little block of code right here. And that's a good way to make sure that it's very clear what it is that you're doing. Another tactic that I do, especially with else blocks, is to put in what it is what that else block means. So, username or password was incorrect. So in doing all of this, extra commenting in code, it does seem like I've just done a lot of extra work, right? I mean, I typed a lot of things that didn't actually make the program do things differently. But what it is that I did was I made it easier to maintain and easier to come back to. When we talk about easier to maintain, we're talking about if you needed to change this for any reason, like maybe I need to go in and change this variable from Johnny to Jimmy, that it's very easy to know how to do that. I can just say, oh, okay, I know I'm in the right file. I know what's happening here. Oh, okay, all right, okay, here's the variable that I need to change, and go in and change that. So it's a really good practice, especially if you work in a team environment. One of the things that's very important is to be an author, or even having another line here that says, updated, and we'd say like it's been updated, 6/6/2013 by Jane Doe, and that way we know, okay, who did the last update to this. So all this comment is kind of you might say it's the paperwork of programming, really. But you can ask any programmer. You will be their best friend if you've done comments like I've done, like you've done really, really detailed comments. That makes it very clear what's going on. So that's why I'm kind of stressing this, and I just keep talking about it, is because if you were in an actual college course where you're doing programming, a lot of teachers have a time period in which they make comments mandatory, and if you don't comment your application, they fail you, and they just say this is unacceptable work. And a lot of jobs are very similar, where they'll say if you don't comment your code, you aren't doing your job right. So start practicing that. It's an essential habit to get into, and like I said, after a while, I don't think about this kind of stuff anymore. I just start going in and doing it, so that it's very clear what's going on. So with that, I will I'm gonna save and exit my application, and pretty much wrap this up. And welcome you guys to subscribe to me on YouTube. Follow my blog, which is jordanjenkins.com. And if you guys feel like contacting me, my contact information is on my site. I'll probably have I'm sure my information is all on Google if you wanted to get on my Google Plus, which I don't check that often. You can catch me on my email. That's probably one of the best ways to get a hold of me. It's really easy, just jordan@jordanjenkins.com. If this is pretty well received by the few people who actually start watching this, what I'll do is I'll go in and go back and do my original lectures that I've typed up on my blog, and I'll do those in videos, and then start moving forward with doing everything in video, if that's a better way of presenting, because I know that this is a good way, since it is kind of a programming is interesting, because it kind of, there's three types of learners. There are kinesthetic learners, meaning that you have to do things like with your hands. You have to actually build things, or actually type things up yourself, or write things down. There's visual learners who are able to just watch what I'm doing on the screen and follow it. And there's auditory learners who require the sound component in order to really retain information. And I do kind of like videos just because it does allow me to do that and kind of hit all three. So, if you guys do have any issues, leave comments in the YouTube, shoot me an email. I'll have a blog linking to this YouTube video, and if you want to put a comment on there, all of those end up getting into my email so that I can handle them. If you want a tracked response, email is probably a good way to get to me. I'm usually good about turning around emails in about 24 hours. I usually try to do less. So kind of a good thing to keep in mind. And while I keep this series long, there probably will be some more advanced stuff. I'm going to try to just keep it all, with the same titles, just to make it consistent for everybody. So once again, I want to thank you guys for your time. I appreciate you guys sitting through about 50 minutes of, fairly dry programming talk, I'm sure. But I'm sure if you're watching this, you had enough of an interest in either Ruby or programming in general to sit down and learn it. So with that, go ahead and hit that subscribe button if you guys would be so kind. I do really like getting those emails that somebody subscribed to me because it makes me feel cool, I guess. And I will see you guys once I release my next video.